Hi everyone, welcome to the stream. Today we will be working on some panelization in KiCad. I have some Hyperram modules that I was working on. I will show you what they are, and we will work on panelizing them for manufacturing. This makes it easier for us to put them on a pick-and-place machine and not have to put one board at a time on the machine. So it is a good efficiency increase if you are doing manufacturing. You probably know about this already, but several people asked me or keep asking on a semi-regular basis how to do that in KiCad and if there is an easy way to do it in KiCad. So the short answer is there is no easy way to do it in KiCad, and it's theoretically and officially not supported, but there is a way to do this, and you can do this, and it's actually not that bad and not that difficult. I figured out a process that works for me. I'm sure there are other processes that you can find. There are some scripts, but the only script that I found so far is an external site utility written completely in Java, which is not like having Java installed. It's not the typical way how you script KiCad. It's not like a Python plugin, which I would wish there was. Maybe there is, and someone in the comments will tell me it's like, look, there is a plugin for it, and I would love to hear about this. But for now, we will be using the workaround in a way to panelize the panels and add breakaway route and tabs or tabs. I will walk you through the process, also explain what they are, how they look, what the considerations are, at least as far as I know them. So to show you what it is, here let's look at the table. So on the table, we have the boards that we will be working on. So this is the, let's do a short fast forward here. It's a little bit too intense in the background here. Sorry about that. That's better. Okay, all right. So this is Hyperram. This is not exactly the board we will be working on, because we will be working on the four chip version of this, but I already sold out of the 4X ones, and this is the only physical 1X one that I have left at the moment. So we need to definitely order some panels. Yeah, we will be panelizing boards of this type, and a panel essentially looks like this. This is a 7-pin adapter that we use for the Blackmagic probe as a breakout of the SWD or JTAG connector. It has a button on it, and it is a breakout board, and you essentially make multiple copies of them and connect them with tabs so that you can easily break them out. And I'm not sure I have a tool here. I will show you. I do have the tool here. So I like using these tools. This is from Hako, I think, is selling them, or CHP. Yeah, CHP. They are. If you look on Amazon for DP-25-N, you will find those tools, and they essentially go in here into the gap, and you can just mouse bite them out. They can be broken by hand. You can break these tabs also by hand, but it is, especially if you have more of them to do, it is easier to use those clippers, and the quality of the breakout is better. There are more ways of breaking out tab and route. Some companies, I've seen that visiting Screaming Circuits, they actually took a table and put a router head from the bottom of the table with a ring that can suck the particulate away, and essentially an operator directly guides this in the air more or less on the router itself and cuts them out. which seems to be a way to do it too. They have pretty big operation, and that's how they break out tab and route, just with their router. And it's a modified, self-made DIY table. So even big companies like Screaming Circuits is building stuff from scratch out of stuff. Yeah, and here are some more examples. This is the HDMI or DVI Pmod, dual Pmod, and here are some icebreakers. So I used to use a 3mm gap between the boards and the tabs, but because that's a more lenient routing bit size for the PCB manufacturer that is doing the routing. A lot of the PCB manufacturers, especially the low-cost ones, they provide, they say it's a 2.5mm router bit. So they are getting pretty angry if you decide to make the slots narrower than 2.5mm. But most of the PCB manufacturers these days are actually have smaller router bits by default. They have not had any complaints since I switched to 2mm gap. And 2mm gap on panels and in quantity eventually adds up to quite a lot of saved PCB space. So it is nice to save some space, some material, and some money. So Oshpark is actually breaking everything out by hand. That used to be the case the last time I visited them. They have V-scoring, and they have a newer version of tabs from their new supplier, which is like this narrow point connection. But they are being broken out by hand. This is the fastest This is actually, I learned from them about this tool. So someone, I think it might have been even Kelly, showed me this tool that they bought to try for the panels at Oshpark. But this is for the sheer massive amount of boards they do. This is too slow and too tedious to use. So they basically just rip them apart by hand, just like this. Just break them out and then put them in the envelopes and ship them. If you see how many boards they break out every day, they have to go fast, and there is no cutting corners here. You have to just break it out. The strong hands of Kelly. Yeah. Yeah. So, anyways. Yeah, Lane is doing that, is doing that these days. So anyways, it really depends on the manufacturer. Some PCB manufacturers or assemblers, they also break out the panels using a CNC router. So I have seen, for example, I do know for a fact that if I didn't throw it away. So the FOMU, oh God, will it focus? Yeah, so the FOMU, this FPGA, USB FPGA development board that fits into your USB port, this one is actually routed out after it is being assembled. They had a few issues where at the beginning when they were starting to produce them, and they were moving around and the router bit just bit into a fully assembled board. They look hilarious, where the components are just shattered and cut into. So yeah, but they sorted it out by now, and these are properly cut out. I don't think there might be some V-scoring happening too these days, but they definitely looked into CNC routing the boards out of the panels. That would be an option. I have a CNC router, but so far it was not. I didn't go and do that project yet to do this. And breaking it out with this tool so far served us well. and the quantities and the amount of tabs we have to break out is still in the realm of doable here. This tool actually got some service life. You see how shiny the sides are. They were black, I think, when they started. So this tool is being used quite a lot. Okay, so let me put this away and look at the desktop. So this is the actual board that we will be panelizing. So I decided that it is a better idea to just make one board, and if we want the 1x Hyperram board, we will just populate one Hyperram module. The only problem with this is that the PCB for this is a 4-layer PCB for the 4x Hyperram, and this board that I made before is for the 1x Hyperram is a 2-layer board. So yeah, there is some price increase, but I think if I increase the quantity, get more panels, the price difference will be not as severe between the 2-layer and 4-layer boards, and I think it is worth it to just consolidate some supply chain stuff here and just use the same board for both and populate only the parts that we need for each SKU instead of having multiple PCBs. So that's what we will be doing today, and there's a legend of what the pins are, for example. So for those that are curious what this is, so Hyperram is essentially an 8-pin SPI interface in a way, and oh, you're working on the Hyperram Pmod right now? Are you changing something to the PCB, or are you just using it for something? So Sylvain definitely did a lot of development for the gateware to use the Hyperram gateware. Yeah, so there is a really amazing stream series from Sylvain doing talking about caching, how to implement caching for a microcontroller or an SoC or a softcore, and you should check out his stream also on Twitch. So it's like to a QSPI, the interface that we have here, yes, and there is this is pretty fast. It is definitely faster than using just QSPI, even DDR QSPI, and so these chips are pretty nice and they're still easier to use than DDR RAM chips that need even more pins. So it is somewhere between PSRAM chips and proper full size like DDR3 or something chips. There's also SRAM, so this is a more modern solution. SRAM is fairly easy to interface to, also needs more pins. It's not as fast, it's a rather old technology, so the chips are expensive. This is a more modern solution that lives somewhere in that ecosystem, and depends on what project you're working on, you might want to go with the Hyperram chips. They are pretty popular now in the FPGA development, and in the sense that you have 8 bits, but you send command and then the data on the same lines. But other than that, it's completely different. Yeah, it's its own animal. So Hyperram is its own animal. This is its own protocol. I'm trying to make more of some kind of a comparison somewhere, but it's really its own thing. So this is 100 megahertz DDR. There is also 1.8 volt version of this. This is what this regulator is for. So this is by default, how we sell the boards not populated. And these chips that we populate and use on the Hyperram chips boards that we sell are the 3.3 volt versions. There's also specific other special version of these chips that is 1.8 volts. And that can be driven with up to 133 megahertz DDR, but the I/O as well as the power supply has to be 1.8 volts. Because of trying to 166, thank you, Silva. Yes, thanks for correcting me. Yeah, 166 megahertz. So the requirement here is you have to populate the correct chips that are not 3.3 volt compatible. Then the I/O has to be 1.8 volts and the power supply has to be 1.8 volts. On the Icebreaker, we can switch the power supply for the I/O banks fairly easily, but changing the power supply on the Pmods, so these pins, is much harder. So instead of futzing around and like rewiring the Pmods, I decided to just put the 1.8 volt voltage regulator on the Pmod that takes the 3.3 volts and steps it down to 1.8. That's a easier solution in a sense. And I'm not even talking about just the Icebreaker. Other FPGA development boards have similar issues where changing the I/O voltage is easier than changing the power supply voltage on the Pmod. All right, so that's a lot of explaining of things that have nothing to do with the topic of today's stream, but I'm sure people will ask. So I decided to go and explain as much as I can what it is, what it does, why and how. Just a fun fact, I posted one of the archive yesterday, and in the YouTube comments below, people are asking questions that I did answer in the streams, but I can understand that there's a lot of content now. There's a lot of hours of me just talking, and so people will come with the same questions over and over again. So I apologize to the faithful people that keep watching all of the content that I will be repeating myself. So I need to repeat myself and tell the same story over and over again, because there are people that just watch it in chunks and don't always get all the information or want to go back and watch the other stuff. So I'm trying to accommodate a little bit broader amount of people. So sorry about that. Yeah. So let's just do it. The first thing is that we need, I usually, how do I do this? So I create a new directory. So this is the directory. Maybe I should open this in the folder browser, projects. Icebreaker Pmod, hardware, Pmod there. And then Hyperram, quad Hyperram. So I have this repository, Icebreaker Pmod Git, which you can find on my GitHub. And this is where the design of the board itself is. So let's see if I can show you. So this is the Icebreaker FPGA organization on GitHub. Okay, got it. Go away. And then Icebreaker Pmod. So this is the designs of the boards. And I do not publish the manufacturing files for panels. So I consider all the manufacturing stuff for bigger batch manufacturing as being completely useless for the majority of the users. If you are a hobbyist, you will not be making panels. So me putting panels and like full manufacturing data into the repository is just making it easier for opportunistic people to just use this stuff. instead of actually contributing to the community. So I'm not putting the panel files into the repository. I keep them on my hard disk here. So just if you are asking, do you have demos of it? No, I don't, and I will not. And if you want to build this for your project, contact me in private. I can give you some templates if you want. If you are building your own project and you want to use a similar system, I'm happy to help you out. But I'm not publishing it for the products that we produce for 1bit². At least not publicly in a public repository. So just to explain what the situation is here. So the boards are here, and you can find it here. And what I do is I just locally for myself create a subdirectory called panel. So let me move this out of the way a little bit. So here's panel. So this is in this directory. Well, let's put that back in. And in that panel directory, we have, I decided to show you here, but anyways, okay. So quad Hyperram, and then version of the project, and then you have panel. And in the panel, I have two KiCad files. One is the panel itself, and then there will be also a template. This is a copied template, this one, from another project that we will adapt to our board design. And all the panelization is being done not in a full KiCad start. So KiCad, usually when you start it, you get this window, this, there we go. So you get this window, which is this like central console startup. You start all the other applications that KiCad is made out of here. But all this schematic editor and board editor and can be started on its own individually outside of this launcher. And we will be using the PCB new, that's how the binary is called for PCB layout. EE schema would be for schematics. And PCB new is what we need, and we need to start it standalone. Standalone, it gets a few additional special menu entries that we don't get in the full start version. So here you will see there is no append board in here, in this menu, which we will need to be able to make our boards. And so I will close this. I will close the launcher, and now start PCB new, and then start the icebreaker panel template KiCad PCB. And just start it from the command line. I'm not sure how to do this on Windows or Mac, or on Mac OS you just do it on the console, you just also go in the terminal, I know that. On Windows, I assume it's similar. You go in the command prompt of Windows and you start it standalone, I assume. So this is how you start it standalone. And then you will get this. So this is the template that I copied from the full, for the icebreaker. So how I like having my panels is with a full frame all around the board for rigidity. And then what I also do is only connect with tabs on top and bottom of the boards, at least in this version, because I have these USB connectors that will be hanging out on the side of the board. And so getting in here with the tool to break off the tabs will become problematic. And the board goes into the pick and place machine, and the pick and place machine will place parts on here. And this gets pretty good. It is still not flexing too much, which is nice. Even the bigger problem would be in the length. So this is more flexible in one direction, this direction, than in this direction. It is much more rigid because it has those tabs. So that's how I put them together and how I decide which way it will go onto the rails in the pick and place machine. So we will have to rename a few things. So on the rail you see it says what project it is on the side, so we can change this and call it like that. So that's one. The thickness of the rail is 10 millimeters, and the gaps will be 2 millimeters. So this, if you can measure things. This is something people are asking a lot too. How do I measure things in KiCad? This is the tool you used for measuring. That's one tool for measuring. It's a new tool for measuring. Traditionally, you were using this entry here, which is the delta distance. So here on the bottom, you see maybe my mouse. On the bottom here of the window, you have the delta. And you can use a view like this, hover with the cursor in a place, press space, and the delta will reset. You saw the delta reset on the bottom there? And then you can move to a different spot and see the distance, as well as distance in X and distance in Y. So these can be used for measuring distances between places. That's the traditional way of doing this. But now, since not so long ago, we also have this tool, which you can click and get a measuring tape and measure also distances between points without having to know that the delta system in the bottom works too. So there are two ways of doing measurement. So this is 5 millimeters. Sorry, I was wrong. Not 10 millimeters, but 5. 5 millimeter rail. So that's one. On the rail, we also have fiducials. So this is something that you can see here. Let's see if we can do some zooming here. Yeah. Woo, there. So this is a special feature that is used for the vision system of the pick and place machine. So you have a small pad out of copper that is shiny against just the substrate of the PCB. So there is no solder stop around it. So there is a ring. If we go in the 3D view here, yeah, I know you have trouble. But if you look here, this is essentially just a ring of the PCB substrate and a small copper pad in the center. This is something that has high contrast and can be picked up by the pick and place machine vision system to align itself to the PCB. No matter how mechanically accurate the PCB goes into the board, there's always some variation and some movement, so you want these visual markers. The thing that I had to learn with that, because I couldn't find it really online good documentation for it, is you put 3 markers on the board. The 3 markers in an L shape more or less on the board or locally for a board. And what I thought was, oh, more is better. So I kept adding more fiducials in symmetric way. You want to put them in a way where they can get good offset as well as rotation information so that they know how the board is, if the board is translated correctly and rotated correctly. But you also want to put it in a way that if you put the board in any wrong orientation, so you put it rotated by any degree or flipped around, these fiducials will never align to itself. So the pick and place machine will fail finding the fiducials if the board is put into the machine in some awkward, weird orientation. This is something I didn't think about until someone at a CM told me about this. And yeah, so I'm telling you now, so now you know. So this is this. There is also a question. Oh yeah, Hardware Dev on Twitch. I am panelizing Hyperram Pmods. So the other feature that we have on the rail is this thing, which might be somewhat useful for the PCB manufacturer, but they have their own markers. I just put it. It's more of a tradition now that I put this because other people do it, and it makes it easier for me to make sure that all the layers are actually in the board, which I never had issues with this, and I never really had problems with this. But this is essentially a show-off of all the layers that the PCB is put together out of. So here you see this is all named, and this is 1 on the silk screen, 2 on the solder mask, then the top copper, then inner layer copper number, inner layer 2 copper number, bottom layer copper, bottom mask, and bottom silk. So you see all the layers. And if you look in the window, let's see if I can show you on the microscope. So this is how this thing looks. Come on, focus, my friend. Yeah, so this is how this looks. And you see very faintly, let me get tweezers. You see faintly this 4 here shining through the layer. So there's a thin pre-preg. So how the PCB is put together, you have a thick inner layer. So there's a fairly chunky PCB material that has copper on top and bottom first. And this is the inner layer 1 and inner layer 2. And then after they expose it, etch it, they put pre-preg, a very thin pre-prepared, pre-soaked fiberglass material with copper on the outside to add the top and bottom layers that then they can etch in another step. So this is why the 4 shines through here, but you don't see anything more in these windows. And as well as these windows are empty because they're on the back. So there's 5, 6, 7, and 8. So this is how you can see them. If you shine a really bright light through this, you might be able to see some of it. But to be honest, well, even with those video lights that are super bright, it's too blurry for me to even see through, to be honest. It might be possible to put like alcohol on it to make the material a little bit more transparent, but it is so diffuse that you don't really see anything. Yes, most people only use it for copper layers, for copper layer alignment, but I thought, why not use the other layers too? So I did. This is just how I decided to design it. But yeah, usually you just have the copper layers in those numbers. That is correct. So yeah, so that's the other feature. And so now there is also another feature in here, which is manufacturing or fab notes for the PCB manufacturer. In some cases they read it, in other cases they don't read it. It really depends on the manufacturer, especially depends on if it is like a quick turnaround, cheapo manufacturer. They definitely don't look at this. They're like, I don't care, I will do my magic on the board. They screw up all your board so that it quickly can go on their etching machines, then you get some board and it might work. So that's usually what you get from LCSC, for example, or not LCSC, from JLC PCB. They are so cheap and so quick that one time you send a board Gerber files, you get some squirrely-whirly stuff changed to the board, and the next time it will be something different, because they do some stuff to make it easier for them to etch and manufacture within the day or whatever that they have to make the board. And they will not ask you, they will just do their thing, and you will get what you paid for. And so be aware that they make changes and they will not read your manufacturing notes. But if you have a bigger manufacturer, someone who actually cares about boards, they will usually at least compare these notes with what you submitted on the website. I had that happen actually with PCBWay before. And they did actually ask, it's like, so you stated in this one thing, but you stated something else in the order. Is it okay for us to do one or the other? And then you're like, oh, I either forgot to change it here, or it's a good second catch to make sure that you get the right thing. It is definitely a more traditional old way of communicating with the PCB manufacturer before all the web online ordering pages were as common as they are now. But it is a good practice, I think, to have those notes. Oh, I'm not showing you the desktop. There you go. That's what I meant. There you go. So this is the fab notes here. This is my template for the fab notes. And I should, based on the recommendation from Drew, use LPI 1000 DPI. There we go. So this is the modifier that I wanted to start using. So I was talking on one of the previous streams how I was unable to get anywhere else but from Oshpark this really crisp PCB silkscreen. So if you look on these boards, again, let's look under the microscope. We are getting into PCB manufacturing instead of making panels. I know, I'm sorry about that. But I hope this is also interesting. So if you look at this silkscreen on this board compared, let's see, what can I compare it to? Let's say with the icebreaker. So the icebreaker, you see, it's pretty good, but it's a little bit smudgy. And essentially I squirted on thicker silkscreen. But if you look at the Oshpark boards, they're so crisp, the writing on the silkscreen. I have to say I love this. This is really nice quality. And Oshpark is great for prototyping, and I keep using them, and I will keep using them. But for big manufacturing runs, they're unfortunately a little bit too expensive for what I needed to be. So I have to order it somewhere else. So I wanted to find a good source that can do, and this is not a must-have, but it's a nice-to-have thing that I striving to find at one of the PCB manufacturers. And I could not find anyone who could do the liquid photo imaging in the quality that Oshpark can. So I was asking Drew, and he was like, well, this is still LPI, you use the right term, but the difference is that this LPI that the Oshpark has is 1000 DPI, as far as if I remember it correctly from Drew. So this is what I will start specifying here. They might say, it's like, oh, we can't do that, we don't have a machine for that. Well, then I will say, okay, fine, sure, then just go ahead with whatever you have. But I have a good feeling that new manufacturers, so I started using recently KiCad for PCB manufacturing. They got recommended for bulk production manufacturing. For everything prototype, I use Oshpark, and that's how it will stay for the future, because they have the quality and I trust them and they are good people, and I still want to support them where I can. But for bulk manufacturing, I started using KiCad, and these people seem to so far be very interested in doing what you are actually. KiCad is not expensive. It costs pretty much the same. I'm getting the same quotes as PCBWay from them. And so I was ordering from them, and it is on par with PCBWay, and it's you get really good service because they actually care. They actually are interested in making the thing that you ask them to. I was asking them some weird stuff in the last order, and they made 4 rounds of test boards before we actually converged on something that will work. I have not seen any other Chinese PCB manufacturer go as much out of the way as they did. So they won my service, or me as a client, for sure. And the pricing is very reasonable. So that's my current take. We will see. I have to make some more boards with them. There's another manufacturing run going through. Yeah, so Bunny is using them. This is who recommended KiCad to me, or Sean Cross actually recommended KiCad to me. This is one of those companies that says, oh, we are PCB manufacturing nerds and we really are interested in the process. And they actually mean it. Most of the PCB manufacturers will just say it as a platitude. So, yeah. The lead times at KiCad at the moment are pretty bad because they have a huge backlog because of the world situation. Yeah, it's still, 4 weeks, I think, at the moment. And yeah, I'm sure it will get better. But they said, yeah, our complete manufacturing line is just running 24/7 now. We have so many orders that we are trying to go through. And I bet because they have higher quality standards than others that it just takes a little bit longer. I'm happy to wait for that if I get the quality that I want. So that's that. Anyways, let's get back to this. We should decide. So usually I have this note in here which helps me with a later process. So I will show you how I put the board into the frame, and then we can adjust the frame as it is to match the boards that are inside. So now to this template frame, because I basically copy this is the icebreaker template. That's wrong. I didn't mean to open this. Still, let's save this. EBP panel KiCad PCB. So I can actually copy this. So rename this IBP panel, and this should be a template. And copy IBP panel template BP panel KiCad. Okay, so that I copied it over. Now PCB new, and there we go. So that's the actual board I want to work on. So this will be the actual panel. Now we have also the 1000 DPI thing in here. Yeah, you're welcome. I'm trying to share as much information as I can about PCB manufacturing and how the market looks like, and yeah, I hope it's useful as always. Okay, so let's import a board. So file, append board, and unfortunately KiCad doesn't remember where you are. It should. So it's another small complaints, and always some small complaints. So my small complaint today for KiCad is when I do file append board, it should be opening the directory that is the current working directory. So the directory I started PCB new in. So that's one way of doing this. Or remember where this dialog was last time and save it somehow so that I can, because currently if I do append board, it always ends up in my home directory and I have to navigate all the way into where I was. So it's pretty annoying. Anyways, fortunately there is this shortcut in here. So quad hyperram, let's go here. So this is the import. So this is the board, and it includes, and I can drop it in here. And this is anchored at 0 points. So I will do the 0 point drop. Or wait, this is 9, 8. Let's see. Yeah, it's easier if I just drop it and then move it to the right position. So I will drop it in here. Let's drop this here. And now we can select it. Oh. It's not what I meant. There we go. Wanted to select it again. And now I can anchor and move. So now we should be, now I can pick up this corner here, or I can pick up this corner, that's fine. And then press space. So while this is the nice thing about measuring using this space, so there are two ways of doing this. I can select something and right click and then move accurate. Where is it? Align, distribute, move exactly, which is a dialog, and then you can move it with numbers. So that's one way. The other way is to pick up a point. This is a more traditional way of doing this. Pick up a point, then it will anchor to the grid. Then I can go in here, press space, then the delta resets, or Control M, yes. And then I can move essentially 2 millimeters, 2.5 millimeters down, and 2.5 millimeters. Oh, this is 3. This is still the old one. Huh! These are still old tabs. Interesting. I forgot about this. So this template actually uses the old tabs. So let's replace them. So this is OSH tab. This is in my pretty KiCad libs library, and this is based on the design that you can find on the OSHpark website. So if you go, I think tab design, tips and tricks, ProtoSnap. Yeah, so there is some really good articles on the OSHpark website where you can find tabs, tab designs, and I'm sure there was also a just a tab. Yeah, there we go. There is some design recommendations for tabs, how they should look like on the OSHpark website. So mine is based on those dimensions, but metrified. So this is imperial measurements, and I converted it to metric and took like a little bit closer measurements based on the metric system, because I design my boards mechanical and electric in metric as far as I can, and it's only broken by the imperial connectors, which are also 1.27 millimeters or 2.54 millimeters pitch, which is also doable in microns. So anyways, I need to change this mechanical to the 2 millimeter mechanical. So let's swap this. And I can actually do this for change footprints with identifier. So this is the powerful menu where you can not only replace the selected footprint, but also change footprints with the identifier so-and-so for the one I want. So these footprints are now all adjusted. I could probably just look for a different template that already uses the 2 millimeter tabs, but that will work too. And so these, unfortunately, the footprints do not have edge cut layer drawings on them. So I didn't do that. I have to do it separately, which is a little bit annoying. But it is what it is. And at the moment, it is not that relevant anyways, because I need to place this guy first and then figure out where the tabs will go anyways. So let's do this. Again, let's do this. Let's align in the corner, and then we can move it again. Move. Space, and then 2 millimeters is what we want in both directions. Then you can use arrow keys on your keyboard to move it just by the grid points. And this is where we are. Bam, let's place it here. And one more thing that I want to do. So when I import these, if I have to make any updates and re-import stuff, I will have to do that every time. But before I duplicate this board, I need to do the changes that will be duplicated all around. So what I want to do in this case is remove the silkscreen here. So let's edit the footprint. I can edit this here and just get rid of the protruding stuff. So that's one way of, so this is also an interesting thing that you might not know, is if you select items in KiCad from left to right, then you only select the stuff that is within the square. So you have to do this if you want to select just the pins. There is, if you select from right to left, then it will select everything intersecting, which is very useful to have as an alternative. So for example, it didn't select the tips here because I went from right to left and it was only selecting the lines here. So it's a nice trick to know that KiCad is, and you see the difference between yellow outline select and blue outline select. So from right to left is blue, and from left to right is yellow. So that's a new useful tool. So I will delete this, and I will select this, and we should delete these. We don't need them here, and then save, and then we do that same thing for the other Pmod to remove the pins. I use, as I said before, I use metric for everything, and I only do Imperial type of stuff for stuff that is made in Imperial, for example, connectors. So if I lay out these normal 0.1 inch connectors first to get them out of the way, and then do the rest in metric. Yes, for schematics, I use whatever the default is, and the default in the thing, it's just a 0.1 inch grid, and that's, yeah, I didn't touch that. The industry for the PCBs, at least from the mechanical standpoint and talking to the PCB manufacturers, they all just switch to metric by now. They can handle your Imperial designs, but they are basically converted to metric anyways. So all the modern PCB or Gerber management tools are pretty much all metric. I'm glad. I hope that's useful recommendation there. Yeah. So good. So now we have this trimmed off because that's not necessary. And now what we can do is put the tabs on. So I don't want to do it yet, but I can show you what we will do later is we will select this board and then use the create array tool to multiply the board around on the panel. So we want to do that as late as possible and add as many copyable features to the board, to the one single instance of it as early as possible. Yeah, mill is, yes, this is in PCB. So you have mill in PCBs and thou in mechanical design, which is very confusing because in Britain, I think people use mill for millimeter. So you have to be very careful what context you are in. It's context sensitive. Yay, language. So yeah, in the machine shop, yeah. The machinists like to poke fun at electrical engineers for using mill for thou. I've seen that plenty on Twitter too. Okay, so what we need to figure out, I don't remember, what is the length here? I should have that actually written down, but so this is 20 millimeters and a half is along the PCB. So we need to be 10.25 with this tab. What happened? Why did you jump, my friend? There we go. So let's do this and then space and then 10.25. We don't really have to be on center here. We could theoretically be just 10, because then I have to go into 50 micron stages, and I don't really want to do that. So I probably will have it offset slightly to the left, and that should be fine. Yeah, let's do that this way. And we can adjust this. So after you do this once for the board, if you change the boards itself, it is much less work than it is now, obviously. And I probably want a tab somewhere here to stabilize it. In theory, I could just leave it and just have. So the idea I have is have 2 rows and then 5 deep for the panel. So that should, so that's the idea here that I had. I didn't actually spell it out. Where's the board? What did I do with it? There. So essentially have something like this, and then 5 deep. And that will fit nicely in the rail, and it won't have too much flex. So it should be 10 boards in one run. That's pretty fine, pretty good, especially if we do the 4X ones. This is a lot of Hyperram chips just going out of the tray, matrix tray. So I think having 40 chips going in one go, in one round, is a decent pace. Trash bag cats. That is a good one. That's a good joke, actually. Are you making trash bags? Oh, that's hilarious. That's a good one. Thanks for sharing. That's great. So we need 20.5. So this step should be here. So it is. How do we do this? 5 by 2. So y, x5, y2, and then step in x is 20.5 plus 2, so it's 22.5. And then in y will be, we will need that a few times, the measurement, so that's why I'm doing it now. And step in vertical will be 42, so 44. 44. And now I still need to add that tab on the left, so let's just steal one. Because they will copy themselves, don't worry about it. Okay. Are we not aligned for some reason? Let's see. Space. So this should be 20 millimeters. Ooh, interesting. Oh yeah, no, of course, because of the capacitors. This is not great. Like having it so close to those vias is not wonderful. Yeah. Yeah, these chips are not cheap. So yeah, let's better assemble it, right? Yeah, that's why probably 10 boards is more than enough per assembly run if things go wrong. Although it's just solder paste, you could clean them and put them back in trays. It's salvageable if something goes wrong, but don't, like if you reflow it and you have a bunch of broken boards, you have to reball all of this stuff. Oh god, I don't even want to think about this. Sylvain, you're generating anxiety here. Stop it. Oh god, yeah, that would be horrible. Okie dokes. So we can add on the edge cuts, can add some traces here, there, and let's add it here. Bam. We will need to cut this out. This is something I have not found yet, a good way to just break graphical lines. That would be nice if there was a good way, if you could just clip it here. I don't think you can. Properties. Yeah, I have to just manually move this stuff around and then fill it out, which is a little bit annoying. Okay, so let's do this. It's not end of the world, it's just small conveniences that would be nice. Like that, and this and this. So now we can open the windows here in the board outline. Not zone outlines. Are you being a jerk again? Yeah. I keep having those issues with the selection where I have to override it with Alt. It's really annoying and I don't know why it is. It might be related to the GNOME Classic that I'm using for some reason, or 2 monitor setup or something along those lines. Yeah. I don't know what the issue is, because the KiCad developers say they cannot reproduce the issue I'm having. So there's plenty of streams showing that I'm having selection issues. It's like, yeah, why can't I? Why is this menu not showing? It's showing all the zone outlines. All the zone outlines are here, but the graphical line is not in this menu. Why? No one knows. I have to go Alt and select, and then it selects it. It's like, what? Why? Why is this an issue? I don't understand. Okay. So that's that. And then we want to select this fella. And we can do the horizontal copy, create array, and then horizontal just 1, 2, and 0. So maybe this is 1. And then horizontally we can do the 22.5. And vertically would be 42. No, 44, right. Oh, I think I'm wrong. I think this should be another millimeter down because it's 42, right? Yes, 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 yes. There is a selection filter. You find it annoying to use? I find it totally fine to use. So you go select and then select filter selection, and then you can select which, if you want, what types of objects you want to be included in that selection. I use that quite a lot, so it's not bad. I don't know. I don't hate it or anything. It's very useful actually and powerful. I should go with 1 millimeter lower to here. So that's right, because this is, let's check. Yeah, it's 44, so it's 42. So I should be 41 down. So I'm 1 millimeter off. Yeah, so that's correct. Ugh, God. This didn't used to be an issue. It did not used to be an issue. Okay, so cool. So that's adjusted. Now let's do create array, and then 1, 22.5. This fails, right, because it just does it here, right. So it should be 2. Am I forgetting something? Oh, horizontal spacing, vertical spacing, that's fine. So it should be 1, I think. Yeah, there we go. Okay, it has to be 1 and then 2. Okay, fine. I have not done that in a few weeks or like months actually. So that's why. So we are doing the opening here. And then opening here. This is all I'm doing here is actually creating those openings. And I use the copying of those tabs as a reference. And now I can delete it. And then we can do the same thing for here. Create an array, and we do 1 and 2. Let's see, that should have done it. Perfect. There we go. 1 and 2. And backspace, very good. Now we can delete these because we will have to redo those anyways. These have to be copied later, so let's not have them in here either. And now we can select this. And now that we have the openings on the bottom and on the side, we can make an array out of this. And we do 5 horizontally and 2 vertically. So there you go. Now we have all these traces. We can disable them because we don't care, or this is flywires, so we don't care about them, so we can disable them. The important thing is to remember that you have to use the array tool, because if you use cut and paste, at least the last time I checked, it might have changed by now, but cut and paste doesn't copy net names for copper. So each these lines have their net names, and if you happen to refill the board in some way using the copper refill, so if you look at this, the copper fill, if you try to refill it now, it should still work fine. I rather not do it at the moment, but it's like if you want to refill it, you could, if the net names are retained. If you just do copy and paste, which you can also do with copy and then paste, then all the net names were deleted in the past. It was, according to Wayne, so dangerous to copy net names that he rather not have that in the feature set because of reasons. I understand that, but it probably should be an option to copy with net names or copy without net names maybe. And that's why you have to use the array tool that does copy net names, unlike the copy and paste tool. So that's why we are using that as a workaround here. Yeah, so that's that. And now we can also add these. So we can use this to create another row that will stay there in the template. Create an array, and then horizontal count is 1, vertical count is 2. So that should copy them to the bottom here. Very good. And we need to copy this like this, and then make a create array, and then do 2, 1. Okay, now we have those here. And now we can adjust everything else in the board. So the frame can now shrink to accommodate the board or accommodate the panel. So the way to do that is usually to get rid of these and get rid of these. This is not really necessary to delete everything here. But yeah, something along those lines. At least shorten it. Can adjust these while we're here. There is not really a good order for this. It needs to be done like that, like that. It goes pretty quick when you're at it. Yeah, and a nice script that would do the parameter, and it would be a plugin like the HTML plugin, that would be lovely. So if you have too much spare time and know your way around Python, write some good panelization helper scripts that integrate well with KiCad. That would be nice. Okay, so there we go. So what we need to do is, let's see, I think I will do this. Just move this corner to the left upper and then shorten it. Wait a second. No, I need to just move this just move this. And, oh God. 5, and then I need this corner probably here. There we go. And then space, and then 2 millimeters. 1 and 2. Enter. So that's 1. Then we can move this thing. Oh, this will be also interesting topic here. And then here, and then move. And then space. As it looks, you always have to click on the cross to move part like in Eagle. No, you don't have to press on the cross if you mean the centers of or the anchor points of parts. You don't. I think you can. It really depends. There is some weird issue on my machine that seems to be specific to my setup, where the selection heuristic thing is not working right or well. And that's what's going on in my case. It is not a normal behavior of KiCad. So take it with a grain of salt, what you're seeing here a little bit, because this should actually work much more smoothly than it does seem. And the selection should work much easier. So this is move, I think. This will move the whole trace, yes. So I have to use just this and then move it here. And space, and then this should be 2.5 millimeters. 1 and 2, 1, 2, 3, 4, 5. There we go. 2.5, so that should align there. Space, then 2. 2 millimeters, perfect. Okay, so these are, even the ends are aligned. That's nice. Now we can move the rest of the frame, I think. So let's do that, and then space, and then move. Two millimeters and 2 millimeters. 2 millimeters. Ah, what did I do? Press the wrong button. There we go. Okay, enter. So that's placed. Now we can shorten all this and adjust it. So first of all, let's. So this is in millimeters. So this is an interesting trick here, to have both measurements in metric and imperial. So this was millimeters, and that's what adjusted it. If I move this guy, it will switch to metric. Ba-bump. Oh no, it stays metric. Oh, that's a new change in KiCad, right? They do retain which units they are. They used to change this. So now it retains what system it is set in. Right. I completely forgot. Yeah, it used to be that I had to change the system that I'm actually have my grid in to switch the system. They changed that, which is very nice. Yeah, I will. So I explained that a little bit earlier in the stream. So I don't share this in the template stuff. at least not for a specific board. I can share maybe something unrelated. The problem with sharing a fully manufacturing data for products that we make is that it is usually, besides, if you want to use it as a template for your own project, that works perfectly fine. But there's unfortunately a little bit too many people that use it to just crank out cheapo knockoffs. No, not knockoffs. It is open source, so it is allowed per se, but it's just they're not contributing to the community in any way. It's or not supporting the project in any way. So I feel a little bit, I want to offer it open source so people can make their own boards, solder their own boards, and share them. But yeah, an empty template, maybe I can do that. Yeah, that might be possible. Second question, do panels have a fixed size, or do they need to ask the manufacturer how big panels they're using? So the manufacturing panel, so there are several layers of panelization. Manufacturing panels at the PCB manufacturing plant, they are, I think, 24-inch square, something along those lines. So they are pretty chunky things. And they or 24 by something inches, and so they are pretty fixed. There are probably maybe two standards of smaller panels and bigger panels, and that's pretty much it. There is some cutoff, there is some blah blah blah. So this is not like a two-layer board. You can fit more actual real estate of finished boards on a two-layer panel than a four-layer panel. This is something you should ask the Oshpark guys. It's like, there's a lot of variability. Four-layer boards need more shrinkage. If it comes to the panels for manufacturing at a CM for manufacturing boards in bulk, talk to your CM and let them do the panelization the way they need it for their machines. Their pick and place machine, their stencil printer for the best efficiency of manufacturing. Do they want flipped boards so that they can do just two runs of the same setup? There's a lot of variability. If you're doing it yourself, you have a pick and place machine, well, then it is up to you. And this is the case here. I make the panels for how my pick and place machine requires it. I don't think I would do the panelization if I didn't do the assembly myself too. I would actually send the Gerber files to my CM for them to panelize it, or at least give me a guidance how they want it panelized if I want to save some money by trading my time for some money. So it's really depends on your situation and how you want it. If you have a CM, just give them the boards for one board and let them do it so that it is best for their setup. Yeah, you're welcome. I hope that's useful. Yeah, I think you are right. I should at least share my basic template in some shape or form. Come to our Discord and I will ask me again on Discord, and I will try to put something together that is a good representation of how the panel frame, how I make them. So that might be a good starting point, and I will share that. Oh yeah, you're welcome. I'm glad it is useful. This is why I'm doing it. I want to, for as many people to learn and be able to make their own PCBs and get into this hobby or job. This used to be a hobby, became my job. And so it is nice to share this information. The opportunistic part that I was talking about, it's like this is a price to pay for all this. That's fine, but it's sometimes slightly frustrating to see where it's That's why I'm talking about this a little bit. I'm trying to stay positive. We have enough negativity in the world. It's like I understand why people do it and why people support it, why people pay for it, why people buy it from other vendors. But yeah, I do appreciate the support for those that are actually putting the hours, weeks, months of work of making this kind of stuff. And so go on Tindy and buy your products directly from those that created it. So yeah, there we go. Yeah, we should move this also to a more central position. So this should be in the middle of this board. So this should be an easy thing to align. And then move. I can zoom out without moving it. Can I zoom out without moving? Yes. There we go. So that's that. Very nice. And there we go. So now it is basically just clean up and closing it up. And then we can move also the fab nodes here. Oh, come on. Come on, fab nodes. Like this. Yeah, and even though I'm saying it's like I will share this template, I think there's a lot of variability, and each person has their own style and their own requirements for manufacturing. So I encourage you to make your own templates for your own panels the way that you feel like they should be. So it is all also very artistic in a way, where you can decide what is the important stuff. For example, I have those drilled holes in here in the 3 corners. They're for locating pins if I would need it. And I've never used those locating pins so far. I was thinking maybe at some point I will have stencils that have locating pins, and I use machined ground precision pins to put in those holes so that I can align the stencil to this. But so far I didn't use it, and it feels like a bad idea because it would interfere with the squeegee when I go like down. So yeah, it's an artifact from something I thought of doing but never actually did. So yeah, it's just a legacy thing in a way. Technological debt, as some people would say. So yeah. Any chance you would show some DDR or PCIe high-speed routing design? It's beyond my level, but it's be super helpful to see how it works in practice, especially with KiCad. So, to be fair, I have not done... So this is the first design I've ever done that has multiple lines of match traces. So if you look at this Hyperram module, it has all those squiggly lines. This is length matching. Length matching so that each signal has physically the same length of wire, quote unquote, going to the chips. So they are connected like this and then back to the pins, and all the data and clock and chip select, I'm not sure, chip select I don't think is matched. Definitely clock and data are all length matched to each other, so they are all the same length. So high speed or higher speed design is something I am also slowly learning how to do. So I would bet that sooner or later we will have streams where I do this kind of stuff, where I try to do, but I'm myself learning how to do this stuff and what is necessary and what is important. Learning from people that know better than I do, that actually have training in this, like Sylvain Manau, for example, TNT, who is in the chat, or Greg Daville, who actually wrote the script that I'm using for length matching calculations. He did on his Orange Crab, which is his FPGA board, he has on currently on GroupGet. That's the page. On GroupGet, Orange Crab. It's like, is it still running or is it over? GroupGets. Oh wow, I didn't even see that picture yet. Okay. Oh, so the 90 megahertz clock signal is not terrific. I'm sorry. I tried my best to design it as well as I could. I'm sure we can improve it. So anyways, this is Orange Crab. And this is an ECP5 FPGA development board with DDR3 RAM attached to it. And Hyperram or Hyper... No, this is the flash. There's no Hyperram on here, I think. And so this is in the format of the Adafruit Feather form factor. And you see the squiggly lines here? So this is Greg doing some magical stuff to length match the stuff. And he wrote a script that is very useful to do length matching. Yeah, nice squigglies, as we say in the trade. Yeah, I'm sure this will come up sooner or later on the streams, me doing some length matching. That will be fun. I'm sorry, Silva, that it is not as good as it could be, probably. Yeah, we have to improve, and I have to learn more and get better at this. This board is also quite squishy, so maybe there needs to be some, yeah, super good squigglies. Yeah, I should be doing this like squid dance or something now. Oh, God. I am sorry. Okay, so we should put that label also in the center here. Yeah, that's very possible. Okay, and then we can add that one line here for the cutouts. So the cool thing is that after we are done with cleaning this up, we can verify if we did a good job by just running the 3D renderer in KiCad. It will complain if any of the board outlines have issues. Okay, so now we have this closed, I think. So, now it's time to make bets if this will actually work. So now I'm starting the 3D renderer. And yeah, it's not perfect. I somehow missed something somewhere. So the endpoint in 141.5, so 14194, 14194, 141, 141. Oh, I didn't fix these. Right. Okay, so I will fix them in a second. I need to take a very short break and I'll be right back. So we will clean these up and hopefully get a render working in the second round. So I'll be right back. Just give me a second. Okay, I'm back. Sorry about that. Let's fix this. With a single chip mounted, it actually looks better. Oh, that's good. Well, at least it's better to know what the issue is. Yeah. So, Sylvain, maybe there needs to be some additional drivers to improve the situation, or is it mostly a possibility of routing? I know that the Pmod connectors are not really great. Like running 90 megahertz is possible through the pin headers, but I don't think this is great. Well, I hope it can be made working. Yeah, well, we have to talk about this. If you have some suggestions and you think we need to improve some things, then we will do that. Okay. So, let me fix this. Yeah, so I have not done that. That's the easiest way. Reset Public, thank you for the follow. Welcome to the stream. Yeah, follow the channel if you want to get notified when I go live again in the future, doing more stuff, because I will definitely will. I also announced it on Twitter and on Mastodon, on Diode Zone, not Diode Zone, on Chaos Social, the CCC, German CCC channel. So Copera, thank you very much for the follow. Welcome to the stream. Yeah, if you follow, you will also get you can probably set it. It's like if you have this bell enabled, you can choose if you get an email to notify when I go live and stuff. So yeah, Beer Metal, thank you so much for the follow. Okie dokie. So now let's test it again. The second round of bets are coming in, I'm sure. And will it fail or will it work? And it failed. So 130 by 26. Okay, 130 by 26. There's an issue. 130 by 26. Now there we go. This is how you find issues. Oh, this is just going all the way there. Okay, so I guess oh yeah, wow. Oof. That's quite a long one. Yeah, it's really hard to see those. That's why the 3D rendering is a perfect way to check if you got it right. And bam! Now it worked. Very good. Very, very, very good. So obviously, you will not have the pin headers soldered down on the panels. So I will only do the SMD parts. So in my case, these are also unpopulated. There's only one capacitor, I think, that I'm populating here, which is the input 3.3 volts that goes in here. The decoupling capacitors for the Hyperrams and the Hyperrams. And the connectors will be user solderable after, of course, we test them in the test jig. I have a test jig. What? Oh, that took some effort. Don't change your username, people. You'll forget it? Okay. I'm not sure. Fails that frequency too, so the signal integrity isn't the biggest issue. Oh, okay. So you're not getting timing closure yet? All right, cool. Yeah, I should also move the text here to a correct position. And oh, come on. Is it really? Yeah, it keeps not deselecting the other one. It's weird. I don't know what's going on. It's fine. Let's move this one. There we go. So the text is there. Very good. Very, very good. So that's done. Let's save it. So Hyperram board is done. Now what we can do is generate the template that we can use for these boards later. So if I want to re-import the board from the main file, if I make changes to the main file that only contains one board, what I will do is essentially, I will show you what I will delete, and then we can basically work backwards to what I will do to do it forwards again. So I'm not deleting everything, but some logical things that can be then auto-generated with just importing the board, putting it in the right position, creating the notches in the board outline, and then just make an array, and that's it. So this is the major amount of work is always if you do a new panelization, updating the board with new board design is much less work, and it goes much faster. So let me save this. So I saved this. Now we can close. Let's close this too. And now I will copy this. IBP panel KiCad. Let's not overwrite it because that's the only chance. And then template. So I hope Hyperram panel, that's what we were editing. Alternative would be probably safer, where I just do this, open this file, and then do save as, correct? That's probably safer. Save as, template, save, replace. And now we have template here. So now I'm editing the template. And all I need to do well, so Drew, you're asking about my prompt. So my prompt is just pretty much the default setting of oh my Zish. Oh my Zish is the link I gave you, and it's pretty much the default setting. I didn't do much to it. And oh my Zish is this. And I think I gave you the link for that already. And I think this is the default theme that it comes with, that I'm using. Yes, that's that. This is what I'm using. There are other themes too, yeah, you can adjust it. They're pretty fancy themes that use like special characters and use Unicode characters to make arrows and stuff, which is pretty nice. But I went back to a more simpler that doesn't take up as much space. I like to be a little bit more space efficient, and those really nice looking ones actually take up a lot of space. But having a status bar above might be useful. I'm still not settled that this will be the only prompt that I will forever stay with, but yeah. Okay, let's get back to the main topic of here. So now that I am in the template, I can delete things that will not be copied. So let's think about the one board. So if we take this board and we copy it over to the right and to the bottom, we have to retain this tab. We don't need these, but we need to keep the ones on the bottom side. So what I can do is select like this, then delete. This one can be also deleted. And I will show you how. So this is something yeah, so delete. And so now, there we go. Okay, so this would be the state after we import the board again. So what we will do is import this board, move it to this position, cut the notch in the top and the side, use the array tool to copy these accurately over from top to bottom, from left to right, make these notches, and then select this whole thing, go in the array tool, and yeah, you have to, of course, copy these numbers. That's why I keep these numbers in here, 22.5 and 44 millimeters. So array 5 is correct, 2 is the second, then we have 22.5, and then 44, and OK. And this will regenerate the board. So this is regenerated panel. So it is much less work. The only really tedious part is creating those notches in the courtyard or the edge cuts layer again after you re-import the board. Are we crashed or something? Oh, I know what it is. Hello? There we go. It's a little bit heavy. The undo is pretty heavy for KiCad, but it works. Okay, so now I can also delete this one, which will be replaced with a new board. And the important thing is that I forgot to mention is we need to set the auxiliary axis of origin from, for some plot and formats is this one, and we need to set this in the left lower corner. Same thing for grid origin. I tend to put that also in the same spot. This is not, so this is not really necessary for most cases. This is really necessary for me specifically because I am using my pick and place machine, so I want this references to be relative to this corner on my pick and place machine. So I do that specifically for my own reasons, because how I program the pick and place. I do use the centroid data from the main board. So let's save this. Let's save template, panel template. So that's saved. Let's close this again. Let's open that again. Make sure that we still have that correctly. Put the origins, before I forget, back in its place. There, and there. Okay, so that's done. Now we can save this. Now when I open the original file, I also have the origin in a corner there. This way, it is more for the pick and place machine centroid data. That's how they're called. So it's manufacturing data for where the centers of all the parts are for the pick and place machine. So let's look at that really quick. What was going on there? 2 and then KiCad. And if we open this file, so for example, the center at the moment of the grid is in here, which is fine. The more important thing is for me is actually to have this located here. This way, when I do file and then fabrication outputs, there is footprint position file. I have to generate the footprint position file that I reformat a little bit and then use the offline programming software for my pick and place machine to program it. And this is where I load those and then assign it to parts, and then all the placement stuff that the machine keeps like its own database of parts and their sizes and their information, so that it can center them, find what the sizes are, and then rotate it right and find it is its own bag of problems and things that you have to keep in mind. But that's why if I actually set up the pick and place machine, these crosses will end up in a corner of the board, because otherwise all the part positions are relative to a 0 that is located somewhere here, which is very arbitrary and really hard to read the coordinates if you want to debug something. So it is better to place it in some more PCB corner related spot. So yeah, so that would be it. Now that we have that done, it's pretty much straightforward. I will export the Gerber files just like we did in the last stream, where you can just go in here and use the Gerber export file. Even in the standalone PCB new, you can do the Gerber export. So you go on the Gerbers and generate Gerbers as well as the drill files. And then you can send it to the PCB manufacturer. So yeah, that is pretty much it. That went a lot faster than well, not a lot of faster, but it went pretty fast, I think. If I wouldn't be chatting and talking to you, I'm pretty sure I can do a complete redo of this in an hour, and then updating the board probably like half an hour. So it is not bad. Obviously, you see that there is a lot of manual pokeroo and careful, don't make a mistake things. So having a script would be better. But in general, I think it is totally doable to do that in KiCad and make panels in KiCad. But that said, there's not a simple way at the moment, because people were asking, is there a simple way for it? The answer is no, but this is simple enough. It definitely is more accurate. So before that, when I was still using Eagle, the way to do Gerber and panelization, and that was, 4 years ago or something, 5 years ago, it was exporting the Gerber files and then using a panelization Gerber tool that is external. But all it did is put the Gerber files in multiples onto one sheet, and then like married several different boards, then put them together into one panel. It didn't add tabs at all. It didn't add a frame. It didn't add fiducials. Well, you could add fiducials, but it was annoying. So, yeah. Just popped in, so might have been covered. 2 3s. Process node have 2 3s. Wow, that's a quick pickup. Yeah, you're right. There are 2 3 points. Let's fix that. Good catch. Fixed. Thanks. Thanks, Stormcorp. Yeah, you helped. Yeah, you get a I don't know, a star or something. Yeah. So anyways, that said, we did the panel. I need to send that in so that we can make more of these, because the stock is pretty much out now. It's the last Hyperram Pmod that I have left. I should have ordered those panels earlier, but things happen and life happens, and it's sometimes really hard, especially it's like when you are the only person doing everything. It's sometimes hard to get the scheduling so that the just-in-time manufacturing runs smoothly. Yeah, I would love to have a little bit more people involved in this so that we can have responsible people. Yeah. Yeah. Hi, Michael. It's nice to have you here. You are making also awesome boards, so you might have found that somewhat useful or interesting. I'm pretty sure you use other tools for this. Yeah. So if there are no other questions, and if you don't, if I pretty much answered everything regarding the panelization for now, I will wrap it up for today. I'm sure we will be back live with some other topic fairly soon. Maybe we will do something else than KiCad next time. I don't know. Suggestions are welcome. I definitely have to do the wire harness stuff for the Glasgow, so I need to essentially just sit down and crimp those wires and make a prototype. So I don't think this is worth doing that on stream, because this will be really, really boring of me just sitting here and crimping cables. So I probably should just do that and be done with it instead of finding excuses to procrastinate. So, oh, okay. So yeah, I'm glad this was useful. Yeah, I'm looking for other improvements. So for example, what I'm looking forward to in KiCad in general is the more stable Python API in PCB. I'm not sure how the situation is now, if we have a stable API. There was essentially what KiCad had. It had Python scripting for a while now, but it is auto-generated out of the C or C++ API directly. So it changes as the internals of the software change. So you can really rely on staying compatible. You have to keep updating with new versions of KiCad, and it just likes to break. So it's somewhat brittle. In version 6, there will be a stable Python API, which is an abstraction on top of the existing API. And so instead of using directly the auto-generated C Python API, there will be an abstraction layer that will smooth it out and keep backward compatibility a little bit more stable. So there is a designed good API in Python that uses the C API in the backend. So only essentially one person, or the developers of the API, will have to make adjustments when new versions of KiCad come out. And it will be more of a, if we break some compatibility, it is more of a conscious decision than just an automatic thing that comes out of the auto generator. So I'm really looking forward to that, so that the scripts are easier to maintain and people can keep using scripts and develop new scripts that are relying on a more stable API in Python. So that will be great. I hope that some additional tools will come around, that there will be some more UI integration. For example, what would be nice for scripts like the script that Greg did for length matching, it could show the results of the length matching directly in the UI of KiCad. That would be nicer than running it in a separate terminal, because how Greg does it, he currently loads the KiCad file separately in its own script and measuring the lengths and then outputting the changes, monitoring if the file got saved or changed, and rerunning that script. It would be nice if it was a part of KiCad. That said, there's always the danger of KiCad going the path down of Blender, for example, where the developers decide if there is a script for it, we don't need to add it as a feature to the software, which is a terrible attitude and causes a lot of issues for the users, where they have to keep hunting for scripts everywhere because half of the functionality that should be in the software is in form of scripts. So, but after talking to the core developers, to Wayne and Seth and several people from KiCad, they are aware of this, and this is definitely not happening in KiCad, at least according to them. So not on their watch, they said. So they will be keeping adding the features that are central to KiCad into KiCad, even if there are scripts for it. So but some things could be accelerated and stopgapped and creating bridges for usability in KiCad if we had more scripts. So I encourage you, if you have Python skills and use KiCad, write some scripts. I should take that to heart myself and write some scripts. But yeah, I'm usually under time pressure, so it's like it is a fallacy in a way where it's like, oh, it will be faster if I just do it manually and I don't write a script for it. But after you do it 4 times, you could have written the script and done the work. So yeah, I should be writing more scripts for KiCad, I know. Anyways, I hope you had some fun, and thank you for coming in and hanging out. Yeah, we should play with the repo for KiCad. It's a useful tool. There's tools and the scripting console. Yeah, you can run Python scripts directly in a scripting console, which is really powerful. I have not really used it before, so maybe we should look at that. That would be fun. Yeah, and if you have been here, subscribe to the channel or follow the Twitch channel to get notifications when I go live again. Also check out my Twitter. I also announce it there. Our Discord that is being here spammed into the channel by the chatbot. Go to Discord if you want to hang out with other like-minded open source hardware developers and FPGA enthusiasts and embedded software developers, and because there's also Blackmagic Probe people in there, and so we do a lot of stuff on our Discord, and we have a lot of very smart people there that are being very nice and very helpful to answer questions. Yeah, and also if you have some spare money or you want a toy in this lockdown situation, get an icebreaker. The stock in Europe and in Crowd Supply will be restocked hopefully by the end of this week. And because I finally have the icebreakers manufactured, so I appreciate you buying the hardware from me, because that makes these streams possible, as well as all the people that support me on Patreon. That is really, really appreciated. That's incredibly generous of you who do donate money on Patreon. I really appreciate it. It's very helpful. Please continue doing that. That pays for the gear that I use for filming those streams, and this is not cheap stuff, unfortunately. And yeah, I would like to say thank you to the Patreons that have back the channel on the level of shout out. And this is Edward Borden, Jordi Parky Rodriguez, Sid Price, Kelly, Tom Keddy, Drew Fustini, and Go Jimmy Pie. So thank you all for doing this, and thank you all for being here. And as always, if you have been, thank you for watching. Bye!